Okay, and so today we are still getting tricky with it. And again, we're going to look at some practical problems related to our ratios, but also bringing in some extra dimensions of maths into it. Okay, so here we go. We're going to have a look again at another practical problem. So, and this one we can see involves degrees, minutes, and seconds. So, we'll take that into account as well. Okay, so it tells us the story here. It says when the moon is exactly half full, Earth, the moon, and sun form a right angle triangle. At that time, the angle formed by the sun, Earth, and the moon is measured here to be 89 degrees, 50 minutes, and 58 seconds. And the distance from the Earth to the moon is 3.84 by 10 to the power of 8 meters. And then, so in part one here, we're asked to find the measure of the angle formed by the Earth, the sun, and the moon. So this angle here. So the first thing that we're going to do a small sketch, a rough sketch of the diagram that we've been given here. Okay, so here we have our rough sketch of the diagram given to us in the question. So let's get on to answering part one, which says to find the measure of the angle of the moon here. So we're just going to call that angle theta. And so here we say that, well, theta is equal to 180 degrees minus the 90 degree right angle minus 89 degrees, 50 minutes and 58 seconds. And so putting that into our calculator, we get theta is equal to 9 minutes, and 2 seconds. Okay, so that's theta. The reason I'm answering in this form, in minutes and seconds, is because that's what it's been given to us in the question. Okay, so that's part one done. So let's put a red box around it to show that there's our answer. And we can now move on to do part two. Okay, so here in this next question in part two, we're asked to find the distance from Earth to the sun. So there's sun, there's the Earth. So we're asked to find basically the length of the hypotenuse. Okay, so the first thing we're going to do then, we're going to take our right angle triangle and we are going to label the sides of it. So here we're going to say H. We'll use this angle this time, so that's going to be O, and then this would be the adjacent. Okay, and then copying in our mnemonic, oh hell, another hour of algebra. Well, then, and looking at our triangle, so we want to find this distance here. So we're going to call it X, our unknown. So here I have X. So essentially, I want a ratio that involves the hypotenuse, and my other piece of information that I have is O, the opposite, and I have my angle. So I'm going to use opposite and hypotenuse, I'm going to use sine. So I'm going to say here, sine of, so that's 0 degrees, 9 minutes and 2 seconds is equal to, well, opposite is, so here the opposite is the 3.84 by 10 to the power of 8, and that's all over X. And again, I want to get X on its own, so I would multiply both sides by X. So I could multiply here by X and here by X, and that will cancel with that. And so I would divide across then by my sine here, sine 0 degrees, 9 minutes and 2 seconds, which means I do the exact same here. So sine 0 degrees, 9 minutes and 2 seconds. Now when, so, and then just that they cancel here, that they cancel here. So that leaves me here with X is equal to 3.84 by 10 to the power of 8 divided by sine of 0 degrees, 9 minutes and 2 seconds. And very important at this stage here that when you are inputting this into your calculator, make sure that you have changed your calculator. You'll see a button and it says D for degrees, M for minutes, and S for seconds. So just make sure that you have it in that mode, okay? And so then once we input that into our calculator, we get x is equal, and very important with these big distances with 10 to the power of something high, that we don't round off early. So I'm going to put in all the digits that are up on my calculator. So that's x equals 2.445718857 by 10 to the power of 9 meters. And that's our answer here for part 2. Okay, and as you can see, I've just put that answer for x into our diagram, into our sketch here as well, which helps to keep it all together. Okay, so now we'll move on to question 3. Okay, so we're going to look at part 3 here, and in part 3, we're told light travels at a speed of this, and we're asked to find the time taken, and we have our distance here. So it's the speed of light from sun to the earth. So we're going to write down the information that we have. Well, we know so here we've part 3. We know it's a problem that involves distance, speed and time. So drawing Dad's silly triangle here and here. Okay, so I'm just going to write down what I have. I have my distance, and it equals 2.445718857 meters. Our speed, we're told, is 3.0 by 10 to the power of 8 meters per second. And actually, I should just put in here that that's by 10 to the power of 9 meters. Okay, so here by 10 to the power of 9 meters. Okay, and so our time is our unknown, but we know that it is equal to distance divided by speed. So off we go. We're just going to solve this very quickly. So filling in here, I have time is equal to distance, so 2.445718857 by 10 to the power of 9, and that's divided by 3.0 by 10 to the power of 8, and putting that into my calculator, I find that time is equal to 8.1523 seconds. And in the answer, or in the question, I'm asked to the nearest second, so I'm going to say t is equal to 8 seconds. So that's my answer to that part there, and again another red box around it. Okay, alright, so now we'll have a look at part 4. Okay, so coming on to part 4, we're told assuming Earth's orbit around the sun to be circular. Okay, so I'm just going to write part 4 here. Find the distance travelled. So the first thing, the distance of a circle, the length of a circle or the circumference of a circle, we know is 2 pi r. Now the first thing that we have to see here is what's the radius? So the radius is the distance that we're used to here, which is this 2.4457.18857 by 10 to the power of 9. So this here is our radius for our journey, because it's going in a circle around that. Okay, so here we go, we write that out. So 2.4457.18857 by 10 to the power of 9 meters. Okay, and again, we're asked to find this distance and we're to give it in scientific notation. So c equals 2 times pi times our radius. So our 2.445718857 by 10 to the power of 9. And so we just input it into our calculator like that, and we're going to get an answer of 1.54 by 10 to the power of 10 meters. Okay, so that's roughly the circumference or the distance travelled by the Earth in its orbit. Okay, next then. Okay, so here in part 5 then we're asked to convert 365 days to seconds. So here we'll say, well, part V. So I have 365.25 and we have to convert that into seconds. So I know I'm going to multiply that first of all by, well, 24 hours. Then by 60 minutes for each minute in those hours. And then we're converting into seconds. So I multiply it by a further 60 to put it into seconds. So that's going to give me an answer of 31,557,600 seconds. So that's our answer there. Okay, and so in our final part, in part 6, we are asked to find the speed in meters per second at which the Earth travels around the Sun. Okay, and again we know from Dad's silly triangle that speed is equal to distance over time. Okay, and again give your answer to the nearest whole number and note 1 year equals 365 and a quarter days. Okay, so the distance this time is going to be equal to our circumference, which is 1.54 because that's how long it takes to travel a full year, by 10 to the power of 10 meters. Our time is what we've just worked out, and again that's because they say note 1 year equals 365 and a quarter days. So it's 31,557 and 600 seconds. And okay, so just filling that in, we have speed equals 1.54 by 10 to the power of 10 divided by 557,600 seconds. And so that's going to give us an answer of approximately 488 meters per second that the Earth travels in its orbit. Okay, so that's our answer to part 6. Okay, so that's pretty much a long question, but again, it just means breaking it down and again starting off at the beginning where we draw our own sketch of the diagram given. Okay, so that's the most important part, labeling the triangle. Okay, so again, labeling the sides of the triangle and working it out. And then obviously with a lot of these, our other knowledge is being brought in. So here our geometry and here our speed, distance, time. So not one topic in isolation. Okay, so make sure all these notes are in your copy and move on to the next question.